In this video, we're going to derive the double angle formulas for sine, cosine, and tangent. So I'm going to start off working on sine, and the derivation begins with the sum formula for sine, which says that the sine of alpha plus beta is equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Then we're going to say that alpha is equal to beta is equal to theta. And then we're going to replace all the variables in our original formula. So this is going to become sine of theta plus theta is equal to the sine of theta cosine of theta plus cosine of theta times the sine of theta. Combining some like terms, we get sine of 2 theta is equal to, and then these two things are the same, so we're going to have 2 sine of theta cosine of theta. And this is the double angle formula for sine. So I'm going to just save it off to the bottom here. Now we're going to start over, and this time we're going to do cosine. So the derivation begins with the sum formula again. Sum formula for cosine is cosine of alpha plus beta equal to cosine of alpha cosine of beta minus the sine of alpha times the sine of beta. Step 2, alpha is equal to beta is equal to theta. So rewriting our original formula, we get cosine of theta plus theta is equal to cosine of theta minus sine of theta. And here's our first double angle formula for cosine. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta. So there's our first double angle formula for cosine. There are actually 3, so what we're going to do is we're going to clear this up, we're going to copy this, and then this is going to be our new starting point. To get the second and third formulas, we need to use a different formula. So we know from the unit circle that cosine squared of theta plus sine squared theta is equal to 1. Then solving for cosine squared theta, we'll get 1 minus sine squared theta. And then we can solve for sine squared. So sine squared theta is equal to 1 minus cosine squared theta. All right, so we're going to save these for now, and we're going to use one at a time. So first, we're going to plug in cosine squared theta. So this equation is going to become cosine of 2 theta equals 1 minus sine squared theta minus sine squared theta. And so this part's actually not too bad. This second formula here becomes 1 minus 2 sine squared theta. And so we're going to save that off. That's one of the formulas. Now we're going to start over. This time we're going to plug in sine squared. So this becomes cosine of 2 theta equals cosine squared theta minus, put this all in parentheses, 1 minus cosine squared theta. Cosine 2 theta equals cosine squared theta minus 1 plus cosine squared theta. So we have to distribute that minus sign. But on the right side here, this becomes 2 cosine squared theta minus 1. And this is our third double angle formula for cosine. So put that over here. And finally, we're going to derive the sum or the double angle formula for tangent. So I'm going to clear this up, and we're going to start again with the sum formula, which is going to be tan of alpha plus beta is equal to the tan of alpha plus the tan of beta all over 1 minus tan alpha tan beta. At this point, you should know what I'm doing next. Alpha equals beta equals theta. Plug it in. Theta plus theta. Tan theta times tan, not times, plus tan theta over 1 minus tan theta tan theta. All right, and finally, we have tan of 2 theta is equal to 2 tan theta over 1 minus tan squared theta. So let's move some stuff around. Clean this up. Guess I forgot my little pie here. And these are the double angle formulas for all 3 trigonometric functions. Now that we know what the double angle formulas are, we're going to look at a little practice problem. So given that tan theta is equal to negative 3 over 4, and theta is in quadrant 2, we need to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So to start off, what we're going to do is we're going to draw out a little plot here. And then we know that the quadrants are labeled like this. So 1, 2, 3, and 4. Tangent is opposite over adjacent. So we're in quadrant 2 over here. So we're going to draw our line. This is going to be opposite. So here's our theta angle. And then this side is 4. So now we need to figure out what this side is. Quick Pythagorean theorem will tell us that it is 5. So 3 squared plus 4 squared equals c squared. This is 25 equals c squared. C equals 5. So in our diagram, we're just going to replace this. This is 5. Now what we're going to do is figure out what the sine, cosine, and tangent are of this triangle. So we'll do that here. Sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. And this is in the second quadrant, so it's negative for cosine. And then tangent of theta is equal to, again, we already have this one, negative 3 over 4. So we have these. And what I'm actually going to do is I'm just going to make this a little bit easier to look at. We have theta 3, 4, 5. Okay, so now what we can do is we can start working through the things that we need to find. So sine of 2 theta, using our equation on the left here, is equal to 2 sine theta times cosine theta. And then we're just going to plug in our values from down here. So this is going to be 2 times 3 over 5 times negative 4 over 5. Sine of 2 theta is equal to 6 negative 24 over 25. So that's our first answer. Just put this up here. Here's our answer. Okay. Now we will move on to cosine of 2 theta. And in this case, you get to pick one of these 3 formulas. I like to use this one just because it's easiest to remember. So that's what I'm going to plug in. Cosine squared theta minus sine squared theta. Plug in our values for cosine and sine. So this is going to be negative 4 over 5 squared minus 3 over 5 squared. It's going to equal 16 over 25 minus 9 over 25 and we're going to get that cosine 2 theta is equal to 7 over 25. So answer 2. And then finally, we're going to look at tangent of 2 theta. And we have our formula here. So that's going to be 2 tan theta over 1 minus tan squared theta. Plug in our values. 2 times negative 3 over 4 all over 1 minus negative 3 over 4 squared. So this one's not the prettiest to look at, but we're going to have negative 6 over 4 on top, which is going to be negative 3 over 2. On the bottom, we're going to have 1 minus, this is going to be 9 over 16. And then I'm going to make this side 16 over 16. This is going to equal 7 over 16. So we end up getting 3 over 2 over 7 over 16. I'm going to need a little extra space here. So now what we can do is negative 3 over 2 times 16 over 7. And that's going to be negative 48 over 14. And we can divide both of these sides, top and bottom, by 2. So we're going to get 24 over 7 is equal to tangent of 2 theta. So grab all this, and then up here, these are our answers to this problem.